Yeah, online students, is my voice is loud and clear? Online students, could you please confirm? Voice and able to see my screen, right? Anyone facing any issue? Everyone, it is clear now? Done. Okay, guys. So, as how we have joined the class today, continuing the same way for every day. Okay, right? I have discussed already the steps to join and to create that account in the WebEx, right? Continuing the same. And coming to the today's class. So in today's class, we are going to discuss the next topic of statistics. So in the previous class, we have covered in terms of various related to statistics. Just as a small recap, what are the things we have covered in the previous one? So I have discussed with you initially starting from the measures called as mean, median, mode. Next, minimum, maximum, range, deviation, and square deviations, mean square deviation, root mean square deviation, and Bessel correction. Why we have to consider n minus 1, coefficient of variance, and percentile, quartile, IQR, okay, lower limit, upper limit, and based on this outliers. Till this we have completed, right? After completing this one, I have discussed with you the distribution. In the distribution, I have told you the frequency distribution, and within the frequency distribution, I told you, and within that again, discrete frequency distribution and continuous frequency distribution for how the continuous variable we have to do, and even cumulative distribution, and this cumulative frequency distribution should be applied only on the continuous variable, cumulative frequency distribution. And cumulative frequency distribution should be applied only on the continuous variable, not on the discrete variable, only for continuous. Frequency distribution can be applied on the discrete variable, along with the frequency distribution can be applied on the continuous variable, right? From there, we have discussed the probability distribution. What is meant by probability, and how to calculate the probability when the given data was given to you. If the data was given, that part only we have completed. And along with that, I have explained for you the probability distributions also. And I have discussed with you the discrete probability distribution and along with the continuous probability distribution. Continuous probability distribution. These are the things which we have covered. Continuous probability distribution also completed. I mean, whatever the data you are having, with respect to the 30 to 40, if you are having one record, divide by total number of records is nothing but probability, and distribution is nothing but same thing you are going to consider here in terms of from 30 to 40. What is the probability? On the y-axis, you have to write the probability. If you write on the y-axis for the same 30 to 40, if you are considering 30 to 40 on the x-axis, and if you are writing frequency on the y-axis, it is called as frequency distribution. If you write probability, it is probability distribution. So 30 to 40, 40 to 50, 50 to 60, same. No difference in the x-axis, same to same. Just y-axis, you have to write the probability. How to check that probability means divide by total number of records. Here you will write the number of records. Here you have to divide by total number of records. That is the only difference, right? Now, and we have also discussed in terms of continuous probability distribution, and now we are moving on to the next one called as types of distribution. Okay, types of distribution. అవును, అందులో ఒకటే చెప్పాను, అదే చెప్పాను ఇప్పుడు కూడా, ఒకటే చెప్పానుగా. Okay, so here we are having in terms of continuous probability distribution. Here we have discussed first what is probability and how to calculate the probability. Calculation of the probability we have discussed. Calculation of probability probability when data was given. We have seen how to calculate the probability when data was given. If the data was not given, how to calculate that we have not discussed yet. That we'll see. Okay. And also we have discussed probability distributions. Okay. So probability distributions, discrete probability, continuous probability. And also we have discussed cumulative probability distribution. Cumulative probability distribution, that is total number of probability will be always equal to 1. While calculating the cumulative probability distribution, we are calculating from the starting, right? We have discussed every time from the starting we have to calculate the total probability. We have to calculate total probability distribution. Okay, cumulative probability distribution. Okay, now coming to this one more time as just as a small recap of for discrete variable. Let us take for an example for discrete, for an example for continuous, and let us complete in a short way. I'm taking a small data set called as gender, male, 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 female, female. That's it. For this first frequency distribution, that is males with respect to a count of 3, females with a count of 2. It is called as count plot. And where you are having the frequency on the y-axis and distribution on the x-axis. Similarly, you are going to take probability on the y-axis and distribution on the x-axis, where you are having this one as 0.6, this one as 0.4. The reason behind this is 3/5. This is 2/5. Right? This is for discrete variable. And if you want to show as a table, if you have to show as a table, what is the table you have to consider? Means category. What are the category you are having? Frequency and probability. Category is male, frequency is 3, probability is 3/5. Category is female, count is 2, probability is 2/5. Okay, this is table. Out of table, first you have to consider the category. Heading is category, followed by frequency or count, followed by probability. Okay, don't write in the notes shortcut as F. If anyone are writing this one in the notes, don't write here F only, write clearly frequency. In my case, there is no gap. You create a big table. Okay, now coming to the continuous variable. First, we are going to take the table. First table I am going to draw. From the table, frequency distribution. From that table, probability distribution. So first let me write the heading called as continuous. First I'll create the table. What is a table? What is the heading of the in this column is interval. It is not the category. It is the interval is the heading. There category is the heading. This is 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100. For the same example of what you have considered in the previous class. Data is previous class. In the class, what are the data I have given? That data. Okay. And for that, I'm first counting the count or frequency. That is 1, 2, 3, 4, 3, 2, 1. Total is 16. The sum of the total number of records are 16 records. Next, probability. 1/16, 2/16, 3/16, 4/16, 3/16, 2/16, and 1/16. Next, if I have to calculate the cumulative frequency, 1, 3, 6, 10, 13, 15, 16. This is called as cumulative frequency. Means 30 to 40, 30 to 50, 30 to 60, 30 to 70, 30 to 80, 30 to 90, 30 to 100. Okay, that is meant by cumulative frequency. Next, cumulative probability. 1/16, 3/16, 6/16, 10/16, 13/16, 15 by 16 and 16 by 16. This is called as cumulative probability. According to that, if you take this interval on the x-axis, frequency on the y-axis, means if you consider first two columns and if you draw the diagram, it is called as frequency distribution. If you consider the interval on the x-axis along with the probability on y-axis, it is called as probability distribution. If you consider interval on the x-axis, uh, cumulative frequency on the y-axis means it is called as cumulative frequency distribution. X-axis is always distribution. For continuous variable, it is interval. For discrete variable, it is categories on the x-axis. What you are considering on the x-axis? X-axis interval, y-axis with cumulative probability if you are considering, means first column and the fifth column if you are considering, it is called as cumulative probability distribution. Is the point is clear? X-axis always fixed. X-axis is always fixed. Okay. For example, if for x discrete variable, heading of discrete variable, for discrete variable, if x-axis, what are the x-axis is there? If x-axis is categories, what are the categories are there on the x-axis? That is nothing but distribution. Okay, x-axis you have to consider as categories. What are the categories are there? Categories on the x-axis. And y-axis, what are the y-axis you are having? If you are considering y-axis as frequency or count, out of these two anything, it is called as frequency distribution. Discrete frequency distribution. Now the same thing, if you are considering, if x-axis is category, y-axis is probability, it is called as discrete probability distribution. Discrete probability distribution. Now same way for continuous. Instead of discrete, continuous. For continuous variables, where x-axis is interval, where you are having the x-axis as interval, that is distribution. X-axis will be interval, that is distribution. And y-axis, if you are considering the frequency or anything, it is called as continuous frequency distribution. And similarly, probability means you are having the continuous probability distribution. For discrete variable, x-axis should be the categories. For continuous variable, x-axis should be the interval. That is the difference. For both of them, x-axis is called as distribution only. Is the point is clear? Now, if you are considering the x-axis interval and y-axis cumulative frequency. Cumulative frequency. Then in this case, it is called as cumulative frequency distribution. You particularly no need to say continuous because automatically it is continuous only. Cumulative is applied only on the continuous. You don't need to say particularly like that. And similarly, cumulative probability. If you are considering on the y-axis cumulative probability, it is called as cumulative probability distribution. Okay. Completed? Everyone? All the 6. Discrete frequency distribution diagram is nothing but count plot. Discrete frequency distribution we represent by count plot. And continuous frequency distribution, whatever we are having, this is nothing but histogram. The plot name is called as histogram. Count plot, and it is called as histogram. Plot name is called as histogram. Concept name is called as frequency distribution. So in the interview, they'll ask, what is histogram? It represents the continuous frequency distribution. What is count plot? It represents the discrete frequency distribution. Okay. Representation is plot. Now, here coming to the point of next one, within the distribution, okay, already we have completed in the last class the distributions and the plots, how to make the plots and everything. So here, just I'm going to consider one more time the data set. So this is the data set, and in this data set, if you take different columns are there, various columns are there, like gender, marks, okay, and in terms of next one is UD, that is uniform distribution, X, Y, Z. These are the different columns which we are having. Now, out of these columns, marks and gender column, we have used for our calculation of discrete probability distributions and discrete frequency distribution purpose or continuous and every purpose. These 2 columns only we have used. Now I'm going to use the remaining 4 columns. Balance 4 columns what are I'm having, I'm going to use them now. In that first column is UD. Now what is meant by UD? So let me take here the histogram of the UD. If I take the histogram of the UD, okay, it is asking to import the SNS. I'm going to import the Seaborn as SNS. Now, if I open the histogram of this particular column UD, can you see all the bins are in the same height? If every bin is on the same level of height, it is called as uniform distribution. If all the bins are in the same height, it is called as uniform distribution. Means every interval has the same amount of count. Every interval has same number of records. What are the interval size you are considering? In that given interval, if all the intervals are having same number of count, then it is called as uniform. Means from 30 to 40, if you are having one student, 40 to 50 also one student, 50 to 60 also one student. For every interval, one student only is there. One student or 2 students or 3, but constant. Okay, then it is called as uniform distribution. Okay, if it is not constant, it is called as non-uniform. Second one is non-uniform. So majorly we are having uniform and non-uniform. And this logic should be applied only on the continuous variable. This logic is not applicable on the discrete variable. Okay. So whatever we are discussing here for discrete variable, we are having mode. We are having only the probability. Only 2 things are there. Mode is there, probability is there. Other than mode and probability, nothing is available on the discrete variable. Measure is only mode. Other than statistical measure of mode, anything else is there means probability. But only for continuous variables, we are going to apply all these things. Uniform distribution, non-uniform distribution, all these things we are going to apply only on the continuous variable. Don't apply on the discrete variable. As since I'm not typing this statement, some of the students will listen to my words and they'll try to keep in the brain. And when after 2 days, when I share the one data set, now for that data set discrete also they'll write in the notes as uniform distribution. Okay, since I have not written the notes, if I'm discussing something, please write in your notes clearly. Okay, for histogram only we have to apply types of distribution. What are the types of distribution are there? It is applicable only on the continuous variable. It is not applicable on the discrete variable. Done? Now, next one is, I'm going to consider still 3 columns are there. Other than UD, I have created multiple columns to show one example, one column I have taken. Basically, these are the examples. Okay. Now, I have taken the example of X column. And in this X column, if I apply the histogram, and what are the histogram you are seeing? It is a non-uniform distribution because all are not in the same height. When all of them are not in the same height, all the bins are not in the same height, it is considered as non-uniform distribution. And what are the non-uniform distribution you are having? In that, again, it is subdivided into 2 parts. Non-uniform distribution is divided into 2 parts. First one is called as symmetrical distribution. First one is called as symmetrical distribution. Second one is called as non-symmetrical distribution or unsymmetrical distribution. First one is called as symmetrical distribution. Second one is called as unsymmetrical distribution. Symmetrical distribution, another name is normal distribution. Unsymmetrical distribution, another name is skewed distribution. Okay. Now, symmetrical distribution. What is meant by symmetrical means? Now, here, what is the starting number and what is the ending number? 0 and ending number is 70. In between, center number. What is the center number? That is 0 plus 70 divided by 2, which is 70 divided by 2 is 35. So, at 35, you take some line like this from 35. If you take from 35, how your left side and right side, if it is same, if it is similar kind of mirror, okay, what are the exactly opposite to this side? If you are having the same kind, it is called as symmetrical. If it is not like that, it is called as unsymmetrical. That's it. From the center, you are going to observe whether left side and right side are same. If both are same, is symmetrical. Symmetrical is also called as normal distribution. If both of them are not same, then it is considered as unsymmetrical. Let's take one more example called as histogram on the Y. I'm going to apply histogram on the Y. Now, same 0 to 70, I'm going to consider center. From the center. Now, from the center, left side and right side both are same? No. At least it is uniform. First it is uniform. No, it is non-uniform. Within the non-uniform, symmetrical, unsymmetrical is unsymmetrical. Within the unsymmetrical, left skewed, right skewed we are having. Within unsymmetrical, again left skewed, right skewed. So, distribution of 2 types. One is uniform, non-uniform. Within the non-uniform, normal symmetrical distribution. Is symmetrical, unsymmetrical. And within the unsymmetrical, left skewed, right skewed. Like this, this is the flow chart. Okay. Within the distribution, uniform, non-uniform. Within the non-uniform, again 2 types, symmetrical, unsymmetrical. Within the unsymmetrical, left skewed, right skewed. Now, unsymmetrical distribution. Okay, S is symmetrical, unsymmetrical, non-symmetrical, all the names are same. Okay, you can choose accordingly. 1 minute, where is the chart? Okay. Okay. Now, Sunil is asking, sir, frequency distribution and continuous distribution is this also distribution types? No, no, no. Frequency within the frequency distribution only. The heading of frequency, continuous frequency distribution. What are the types of continuous frequency distribution? Types of continuous frequency distribution. Types of continuous frequency distribution. Is the point is clear? Now, unsymmetrical. It is unsymmetrical or asymmetrical. Okay. Now, left skewed, right skewed. What is meant by skewed? Skewed means one side less number of values are there. One side more number of values are there. More number of records are one side, less number of records are one side. Then it is called as asymmetrical or unsymmetrical, non-symmetrical. Anything is same. Now, which side you are having less number of records? Right side you are having less number of records means right skewed. Left side you are having less number of records means left skewed. Which side you are having less number of records? So how to check? Very simple. See here. Here one record is there. 2 records, 6 records. If you accumulate these three, left side total number of records how many? 9 records. Right side 1 1 1. Total how many records on the right side? 3 records. Left side 9, right side 3. What about the center one? Center one half of 9 anyways. No need to consider. If 4 records are there, 2 records this side, 2 records this side, 3 are there, 1.5 this side, 1.5 this side. So ignore this one. Sir, here 7 bins are there, so you're ignoring the center one. 8 bins are there, then easy now. 4 bins left side, 4 bins right side, we can count. That is still more easy. If odd number of bins are there, ignore the center bin. For center bin, right side number of records, left side number of records. Half of that bin goes to the left side, half of that bin will go to the right side. Ignore that bin, ignore. So 9 records are there on the left side, 3 records are on the right side. So which side it is skewed? Which side you are having less number of records? Right side. So it is called as right skewed distribution. Now, if I take another variable, Z variable. Now this is first symmetric, uniform, non-uniform. Non-uniform. Whether it is symmetrical or I'm going to take here number of bins is equal to 7. Okay. Whether it is coming to that point, uniform, non-uniform means non-uniform. Symmetrical or unsymmetrical? Unsymmetrical. Now from the center is again 0 to 70. Mean between value is 35. Or 7 bins are there means center value is 4th bin. 7 bins are there means 4th bin will be the center bin. For center bin, now you are having 1, 2, 3. How many records are there? 6 records. 5, 2 and 1. 8 records. So which side less number of records are there? Left side. So it is called as left skewed. Okay, skewed means having less number of records. That is meaning of skew. Records, count, not on the bins. Number of bars will be right side, left side same now. Every time. From the center value, how many right side will be? That is the reason it is called as center now. Right? Now, next coming to this next one is called as skewness measure. So here we are going to observe whether the data is normally distributed or not. Means for that we are having the different options. In that first option number 1, based on the histogram. We can say based on the histogram. So I have shown you based on the histogram how to see this one only. Just now what I have covered. X example, Y example, Z example. So these 3 examples you have told. One is symmetrical distribution, which is normal. Second one is left skewed. Third one is right skewed. Based on the histogram only. Just now we have completed based on the histogram. Second option is there based on the skewness value. This is a statistical measure. Through measure also we can say type of distribution. What is a type of distribution to statistical measure? That is called as skewness. Now, what is the skewness formula and how it has to be calculated? For example, some data was given to you. Okay, some data was given to you. How to calculate the skewness? You know how to calculate variance now? I'm explaining everything how to calculate manually also, right? Now, first step is you are going to calculate the x minus x bar. That is nothing but mean. Okay, and after that you are going to calculate x minus x bar whole square, followed by you are going to calculate x minus x bar whole cube also, whole cube, total 3. Okay, x minus x bar whole square, x minus x bar whole cube, total 3 of them you have to count. After counting, first you have to take the sum of x minus x bar whole square, means for this particular column you have to do the sum. After doing this one, x minus x bar whole square divided by n minus 1. For that you apply the square root, which is nothing but standard deviation. With this one is completed. Now come to this column. For every column you are going to calculate x minus x bar whole cube. For this also you do the sum. That is x minus x bar whole cube. You do the sum. You will get some sum. After doing the sum, now you calculate the skewness value. Skewness is equal to sigma of x minus x bar whole cube. That is this value. What of this value you are going to get now? That is on the numerator. Divide by, here you calculate a standard deviation, right? Divide by s cube. S value here you have calculated. That is s cube into n divided by n minus 1 into n minus 2. This is the formula of skewness. How to calculate means in this way. So from here you calculate this value. From here you are going to calculate this value. Already you know n divided by n minus 1 into n minus 2. So that is the formula. N divided by n minus 1 into n minus 2 into sigma of x minus x bar whole cube by s cube, where s is standard deviation, n is number of records. Is the point is clear? How to calculate manually the skewness value for any given data set? 2. N minus 1, n divided by n minus 1 into n minus 2. N minus 1 into n minus 2. Like this, we have to calculate manually the skewness. Or simply, if you want in the Python means, whichever the column you are interested, that particular column dot skew will give the skewness value. Simple. Dot skew. What are the column you are interested? So whichever the column you are selecting, that particular column. Right? Now, sir, what is the advantage of skewness? Now, based on the skewness also, we can tell the type of whether it is a symmetrical or whether it is a left skewed or right skewed. Now, if the skewness value is 0, means it is not having left side less number of records or right side more number of records, both the side equal number of records are there, then it is considered as perfect normal distribution. Perfect normal distribution. Sometimes what happens means we will write left side 8 records, right side 9 records will be there. Means only 1 record will be more. Sir, due to 1 record, we can't say left skewed. It is slightly left skewed. It is left skewed only, I'm accepting, but slightly. So if the skewness is from -1 to +1, if the skewness value is between -1 to +1 also, still we consider as normal distribution only. If you are having between -1 to +1, any value between -1 to +1, we still consider as normal distributed. Why? Because maybe one record or two records will be more, right side or left side. For one or two records, we don't need to that much of difference we don't need to show. Okay. So for example, in your batch, you got with respect to these, for example, 5 students has got the jobs, assume. In 1030 batch, 6 students has got the job, assume. 5 and 6. We'll consider as almost same, or we have to say 1030 batch people are great compared to 9 AM batch. Almost same now. One or two records will not consider. For example, here 5 students, they 10 students miss. Yes, there is a difference, double now. But one or two students will just ignore. So in the same way, if the skewness value lies between -1 to +1 also, it is still considered as normal distribution. Basically, any value greater than greater than 0, that is any skewness if the greater than 0, it is called as positive skewed or right skewed. It is called as positive skewed. It is called as positive skewed or right skewed. Basically, any value greater than 0, it is called as right skewed only. Any value less than 0 is considered as negative skewed or left skewed. Okay. So any skewness value greater than 0 is considered as positive skewed or right skewed. Any value less than 0 is considered as negative or this one. But still we are considering -1 to +1 as normal distribution. So more precisely we can say here, if it is crossing +1 only, till +1 also we can consider as normal distribution only. Once it cross more than +1, we consider as right skewed. Okay, is the point is clear? Similarly, less than -1, we consider as negative skewed. If it is between -1 to +1 also, we'll consider as normal distribution only. We will consider as, but basically it is not the normal distribution. We can negligible values we can consider. Okay, so here earlier we have completed this one, X. From the histogram, what you told as X, it is a symmetrical distribution, which is normal distribution. I'm checking the skewness. See, what is the skewness value? 0. Now, from this, what you are going to say, whether it is left skewed or right skewed? It is a right skewed. You told earlier it is a right skewed. Now, just observe the skewness value also. For the same column, what are the Y column you have considered? From the histogram, you are saying it is right skewed. From the skewness value, 0.69. Any value greater than 0, it is called as right skewed only, right? But still, we will consider as normal distribution. There is no much difference. No, because here small data set. Next, coming to this one, what is basically this is left skewed we have assumed, because left side less number of records are there when compared to right side. Now, if you see the skewness, see, minus value have got, it is negligible, but minus value have got, right? So it is negative skewed. Okay, is the point is clear? Or sir, I'm getting confused with respect to this one, means in your simple notes, you write only with exactly 0 is called as normal distribution. Anything greater than 0, right skewed. Anything less than 0, left skewed. Fix. -1 to +1, as of now, ignore. That is not there. You'll understand in the further. Why we have to consider -1 to +1. You'll understand in the further when I move on to the large data sets. As of now, just ignore. Just you write in the notes, only equal to 0 is called as normal distribution. Greater than 0 is called as right skewed or left positive skewed. Less than 0, only 3. -1 to +1, just ignore. Unnecessarily don't get confused, so that your answer and this skewness value will be satisfied for you. Otherwise, you'll ask again the question, sir, here records and that records. Okay, as of now, just ignore -1 to +1. Only 0, greater than 0, less than 0. Why you have to consider -1 to +1, you'll understand in the later. When I move into the further subject and advance of statistics, you'll understand that later. Okay. Now, third option also we are having to check whether the data was distributed left skewed or right skewed. That one also we can say based on the mean and median values. Option number 3. Based on mean and median values. This is option number 3. So how you can say? So once again, same. Earlier, what are the skewness? What is this? It is a normal distributed data. And according to the skewness also, it is exactly 0. It is normal distributed data. Okay. So as per histogram, it is normal distributed. As per the skewness, it is normal distributed. At the same time, if median and mean, both the values are same, it is normal distribution. If mean and median also same is normal distribution. For normal distributed data, mean and median will be the same. There will be no difference. So since it is a normal distributed now, skewness is 0 and histogram says it is a perfect normal distribution. Let us cross check with the mean and median also. Mean value is 35, median also 35. If your mean and median both are same, it is called as normal distribution. Right? So X column, for X column, I have shown you histogram. For X column, I have shown you the skewness. For X column, I have shown you the mean and median. Now, Y column. For Y column, option number 1, which is histogram. From the histogram, it is clearly saying that it is right skewed. Right side, next number of values are there. Right skewed. From the skewness also, 0.69. It is positive, which is right skewed. Now, for right skewed distribution, mean should be greater than the median. What are the mean values there? The mean value should be greater than the median. Let us take the mean. Mean is 30.125. Median is 28.5. So mean is greater than median means it is right skewed. Is the point is clear? Sir, out of these three, which one is best? Whichever you feel easy, that is the best. There is still 2 more options are there. Option 4, option 5. When I show you multiple options and different, you can select as per your choice. Sir, why are you explaining these many options to us? As yours is a special batch now. One student is, you may prepare in one way. Some students may prepare in some books. Some students may follow the YouTube channels. In that YouTube channel, one of the person will say one of the option. You'll fix that option and you'll ask me. If I show you the easiest option also, you might think that I have not explained that one or something like this. So if I show all the options, you will only understand automatically. Whichever you feel easy, that one you can continue. Okay. Multiple options are there. Out of multiple options, my favorite is second option. Very simple to take. Dot skew. It will give the positive, it gives the negative number. Sign only I will see. Positive sign means positive skewed, that is right skewed. Negative means negative skewed, which is left skewed. Again, drawing the histogram, again confusing with respect to counting. Sir, this one, sir, that one, sir. Simply, I will go with the skewness value. No more discussion for me. Okay? Because the point why sir, you'll see like this. You have to do the detailed analysis. No, sir. See, I'm a student. I'm a learner first. I'm not a researcher. During the learning only, if I do the research means answer is confusion. That clarity is there for me. So when I'm doing as a learner, when I want to learn the concepts clearly, I will not do the research on that. Once I practice 2 or 3 times, 4 times, 5 times, and once I get the subject strong, then I'll start doing the research on that. Why like this? Why like that? Then automatically still more understanding will be there. While learning only, if I do the research means my brain will not support for me to understand the concepts clearly. It will say at the end called as confusion. My brain was designed in that way. So that is the reason I will not do generally the research while learning. If by in the class, what are the examples are something, this is the this one means okay. Where to use, how to use. Why this one only, why that one only. If I do the PhD on that, the topic will not go further, and finally I will not understand the concept clearly. That is my feeling. I'm not saying that this is the right option or everyone has to follow this one only. That is your individual choice. As a learner, I will do learning. Later, when I have to come into the PhD level, I will do the PhD. In LKG only, if I do the PhD means, for doing the PhD, first we have to complete so many stages. Directly in the BTech also, they'll not allow you to sit in the PhD class. First, they'll explain the concepts clearly. And where to use, what to use, how to use, they'll explain. Then they'll ask you to do the some kind of why this way only, that one only, is there any other option? These high intelligent questions you can apply on the later. Generally, they'll say like this. No, sir, in the BTech first class only, I will do the PhD. Why I got like this? If I do means, BTech will not be completed. That one also will not be completed. On the first day only, we call it as confusion. If I'm a general student, if I'm a like Einstein or some Newton or something, means that is different story. I'm not that much of high person now. I'm saying about me, guys. I'm not saying about any person else. I'm saying only about me. Okay, right? Now, coming to the third column called as Z column. Now, what are the Z column? From the histogram, what are the histogram I'm having? From the histogram, I'm going to conclude based on the histogram, that is here bins is equal to 7. Okay. Now, it is concluded that it is a left skewed. For similarly, from the skewness also, it is minus value, which is left skewed. And mean should be less than the median value. Mean should be less than the median value. So from this also, it is concluded clearly that it is a left skewed. So 3 options are satisfying the same answer. Okay. Now, as I've told you, fourth option, option number 4. Okay. What is the fourth option is? By using the density curve, based on the density curve. Density curve. Now, what is meant by density curve? Density curve means probability curve. In statistics, density is also called as probability. Density is equal to probability. In statistics, density is equal to probability. Both are same. Okay. They'll use the technical word called as density in the statistics, and which is also called as probability. Right? Now, based on the probability curve, also we can say density curve or probability curve. Means, for example, for this data, this is the histogram. Now, how to draw the probability curve? Means probability values. How to calculate the probability? Means stat is equal to probability. We are going to write the stat is equal to probability. Here, if I write this one, stats is equal to probability. I'm going to get the output like this, which is this one. Now, if I combine the edges, if I draw the edges of the probability curve edges, if I draw like this, this is called as probability curve, which is also called as density curve. How to get this density curve means you have to write here KDE is equal to true, comma KDE is equal to true. Then you are going to get the curve like this. Now, what is KDE? KD means kernel density estimation. That is the full form. Kernel, K stands for kernel, D stands for density, E stands for estimation. Kernel density estimation, which is also called as density curve. Now, once you get the density curve, what are the density curve you are going to get? If the density curve is symmetrical, you can get here itself, or generally what we'll do is we'll write here histogram. For the histogram, we'll apply the density curve. Okay, exclusively if you want the density curve only, we are having SNS dot KDE plot. This gives only the density curve of what are the column you are looking for. If you take the df of x column, for this column I want KD plot, means it gives only the density curve. This is the exclusive density curve. The curve is symmetrical or unsymmetrical. How the curve is looking as? It is a symmetrical curve. Symmetrical curve is also called as bell curve. It is similar kind of bell. So normal distribution, another name is also called as bell distribution. Bell distribution. Why? Because it forms the bell curve. The reason behind that is it forms the bell curve. Sir, my question is very simple. How to draw this bell curve manually? Very simple. Line plot between. Earlier you have taken the table, one table, continuous variable. What are in the table? What are the 5 columns are there? What are the 5 columns in the continuous variable? Continuous table. Tell me guys, whoever has written. What are the 5 columns? What is the first column? Interval. Next one is count or frequency. Next, probability. Next one, cumulative frequency. Next one. Right? Now, draw the line plot between these two. This one versus this one. Draw the line plot. Instead of the histogram, draw the line plot between these two. If you draw the bars between interval versus probability, what it is called as? Interval versus probability for continuous variable. If you draw, what is the plot? It is called as histogram, and what is the concept is called as probability distribution. Probability distribution. Now I am not asking to draw the bars. I am asking you to draw the line plot. What is meant by line plot? Keeping the values. What are the values you are going to get? The first value, second value, third value, fourth value, fifth value, sixth value, seventh value, and combine all these values is called as line plot. Sorry, I have not explained for you line plot now. Sorry, my mistake. Line plot. What is meant by line plot means each data point. What are the data point is there now? For example, I want to draw the line plot between 2 columns like this, x comma y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What is the first step I have to draw is called as scatter plot. What is meant by scatter plot? This is the point 1 comma 6. On x-axis you have to take 1. On the y-axis you have to take the 6. Keep one dot. This dot is called as scatter point. Scatter point. One point you are keeping. Now for second record, how to keep the point? 2 comma 6. Wherever the 2 is there, and 2 comma 7. One dot. Dot. 3 comma 8. One dot. 4 comma 9. One dot. 5 comma 10. One dot. Each data point, one dot. You have to keep one dot means what you require is one x value, one y value. Without x and y value, we can't keep the dot. One x value we required, one y value we required. Then only we can keep one dot on the graph sheet. It can be minus 1 comma 6 also. If minus 1 comma 6 means we'll keep the dot here. But we require two values. One is x value, one is y value. What x value, what is y value. So once we take the values of x and y, and if you combine the data points in the sequential order, whatever the order they have given, in that order only you have to attach the data points. It is called as line plot. From the scatter plot, next one is line plot. First step, what you have to do? First you have to draw the scatter plot. In the scatter, after drawing the scatter plot in the order, means first this is the first point now. For this point, second point you have to attach. Third point you have to attach. Fourth one, fifth one. Sir, for example, you have got in between something like this 30 comma 8. First one, second one you have attached OK. After that one is 30 comma 8 is there, sir. Here. You have to go to here and from here, here. In the order only you have to go. In the order you have to connect the data points. What are the order is there? In that order only you have to connect the data points. If it is far also, if it is bottom also, if the top also, if it is left side also. In the order only you have to come. You can't stay in the order. Okay. So this logic of line plot should be applied only on the continuous variable. Now see here, when you are having the continuous from 30 to 40, what are the probabilities there? For that you are going to attach the data points. And once you attach the data points, you are going to get the data points in this way. Line plot will be like this. This is called as KDE plot. A KDE plot is nothing but interval versus probability. A line plot between interval versus probability is called as KDE plot. Using the KDE plot, what you are going to get is whether the curve is symmetrical or unsymmetrical. Now, similarly, I'm going to apply for the Y column also. Now tell me for this Y column. Now, wherever the Y column, comma, KDE. I'm writing here KDE is equal to true. Now, whether the curve, what are the curve you are having, it is symmetrical. Now, just instead of this one more time, I'll show you exclusively SNS dot KDE plot of DF of Y column. Now, wherever the peak is there, this peakness will be there, right? That peakness only you have to take the center point. Wherever the peakness is there, that is the center point. Okay. Now, left side and right side, same thing is there. Now, which side you are having the more amount of tail? Tail is on which side? Tail means the curve extension. Which side you are having? Right side. So it is called as right skewed. So how the normal distribution plot will be represented as like this. This is normal distribution. How the right skewed will be represented as like this. So right side tail, extra tail will be there. Some extraness will be there. Up to here it is common. This extra part will be there. Tail will be on the right side. Sir, why the tail will be on the right side? Very simple. Here the what are the bins are there? Their height is less. Less number of records are on the right side. More number of records are on the left side. If you draw the histogram, see. Which side you are having less number of records? Right side or left side? It is clear now? So which tail also will represent the same. Without the histogram, the tail also represents the same. Now, if you are having like this, here less number of records are there. Very small amount of records are there. And when you move on to the right side, more number of records are there on the right side. Which side you are having less number of records? That is the skewed. Which side more number of records are there? That is not important. Which side less number of records are there? That side is the skewed. Is the point is clear? So generally the left skewed will be represented like this, right skewed will be represented so that it will be easy to understand. Right side tail will be more. What are the tail you are having? Right side tail will be more. Okay, that you can represent by using the KDE plot also. Using the KDE plot. Right? Now, these are the total 4 different options. Sir, you told 5th option now. That you will see in the inferential statistics. By applying the statistical test also, we can say whether it is a normal distributed or not. Okay, there is a test for that. Separate test is there. Statistical test is there. That during the inferential statistics, you'll understand. right? Now, is the points are clear? So this is with respect to the types of distributions and different types of measures. Now, in these measures, I have explained for you the skewness also, right? With this, all the measures of things are completed. I mean, uh, different measures. The first one is called as measures of central tendency. In the measures of central tendency, we are having the mean, median, and mode. These three comes under measures of central tendency, and which is also called as first business movement. Why it is called as first business movement? Okay, why? Two reasons are there. One, by default, anyone gives one data set to us. First, we'll go with the average value. What is the average value? If anyone says salaries, okay, salaries of a different students, we'll ask first question, what is the average salary? That is our basic first one. If anyone says that in this class students ages are like this 24, 28, 32, 26, 22, 24, 23, like this, if they say also, first we'll ask the question, what is the average salary? What is the average age? We'll ask first by default, we'll go with the average. If anyone try to explain with multiple numbers, data points, we'll ask the first question. For example, if you say marks, sir, my marks is this one, sir, my marks is this one, like this, if you say, my first thing I will ask, what is your average marks? So that is the reason it is called as first business movement. Second reason for that is your first business movement will have the x power 1. Mean value will have x to the power of 1. Your second business movement will have x minus x bar whole square divided by n or square root, which is standard deviation. So power square will be there. X to the power of square will be there. In the third business movement, that is called as skewness. Skewness comes under third business movement. Okay. Basically, we are having measures of central tendency. Measures of central tendency. Okay. Which is mean. Measures of central tendency, which is also first business movement. How the data was moving, which is mean. Coming to the next one is called as measures of dispersion or spread. Second one is called as measures of dispersion. How the data was deviated. Measures of dispersion means deviation. That is your second business moment, basically. This is your first one, first business moment, and this is your second business moment, which is standard deviation. Now coming to the third one is called as how the data distribution shape is looking like. The third one is called as measures of shape, which is your third measures of third business moment, which is skewness. These are the three. First business moment, second business moment, third business moment. X to the power of 1 will be there in the data. X to the power of 2 will be there because x minus x bar whole square you are going to create in the standard deviation. In the skewness, x minus x bar whole cube you will take. Power 3 will be there. Basically, these are the three most important measures. Actually, we have to discuss only these three. But instead of discussing these three, I have discussed with you so many things. Okay, multiple things. The reason behind all this discussion is to have why they have invented standard deviation. What is the reason and why standard deviation only will consider if outliers are there, none of them is correct. None of them is correct. Mean is wrong. Standard deviation is wrong. Skewness is blunder. Big blunder. Because in the entire data, one record is there. For example, in your class, 180 years person is there also. Due to that 180 years person, till many students will be 22, 25, 25 to 30, 30 to 35. In this range only will be there. If one record is there of 60 years person, assume. In between nothing will be there. Empty bars will be there. Empty bins will be there. that will have again one bin. Now, whenever there is one bin, automatically the tail will be gone to that point. And we call it as right skewed distribution. Okay, due to one record, histogram, that bin we have to represent now. 50 to 60 bin also we have to represent now. So automatically this is distinct, which is far away from other data points. And it is going to be the right skewed distribution in that case. And 100% you will get in terms of more than +1 due to the outliers. Okay. If left side less number of values are there, means also you will get with respect to left skew. Right. So if outliers are present, entire statistical analysis will be impacted. So first we have to do the data exploration, data cleaning, then only data analysis. Many people, what they'll do means 3 of them at a time they'll combine. Okay, when they have given you multiple curries while you are having the meals, are you going to eat separately, or you combine all the curries and you'll eat at a time? That is your choice. Depends. One person, one way. Some persons will say that this taste is very nice by combining the 3-4 curries in a single one. Continue. Happily you continue. Okay. Some person will say separately eating is good. Continue. Whichever the way you are feeling is correct, continue in the same way. I'm not saying this one is only the correct. Okay. Is the point is clear? So at a time, if you can do in the project data exploration, by seeing only immediately, sir, I will do the cleaning now only, I will do the analysis now only, means do. Once you do, again you will come back now. Again you will come to the right process. First in your mind question will be there. Why I can't do this one? Try. What are the question is there? First if you try, and if you fail, you'll understand the problem later. If someone explains for you the problem and if they say that this is not the right one also, generally as youngsters will not be interested. Your experience is why for us? My experience only I want. If you say also I will not follow. If when we don't follow the elder people only, we are called as youngsters. That is the meaning. We have to do, not to follow is our blood group. So generally we'll do like that. And later you'll get the bad experience. Again you'll come back. Then you'll understand what elder people will say. Okay, this is the reason. They already experienced all these things. That is the reason they are saying us not to experience this one. That we'll understand later. Same way. In my company also, as a senior, if I say to my junior something, sometimes he will not listen. Instead of motivating him, or instead of saying that, Arey, you should not do, I have already tried. If I say all these things, instead of that, first you do. He will do completely the project and the entire time waste will be done. Then he'll come back to me. And then he'll ask the question. Again, I'll explain. Then he'll understand. Okay, sir. Next time you only tell me in what way I have to do, sir. Now he'll come into the control. First time only I will not try to control. Do. You will fall now. Then you'll understand. What is the tips I am giving and all these things you'll understand later. I will say in my office. I'm not saying to you. I'm not saying individual person. Example purpose I'm saying. Right? Don't think that you are saying to me only. You are saying indirectly to us only. If you feel means I can't do anything. Okay. But I'm saying from in my company what we do generally. Right? As many students are expecting that class was completed and they have closed the books. So for that reason, I will continue with the next topic. Next topic is, now what are the distribution you are having? This is measures that is continuous variable you are having like this. Now how to calculate the next heading is how to calculate the probability heading. Now they'll open the notes again, they'll write. Open. Take from the back notes, write. How to heading is how to calculate the probability. How to calculate the probability of a continuous variable when the data was not given. When the data was not given to us. Right? When the data was not given to us. For that, as I have told you, we are having what are the options when we are having? Two options are there. When the data was not given, we can calculate the probability based on the two options. These are the two options. Option number one is by using the 68, 95, 99.7 rule. Second one is using the z-score and z-table. These are the two options. Now, we'll continue from here tomorrow. Done? Anyone has any questions? 1 minute. I have uploaded. Check once. 1 minute, 1 minute, 1 minute, 1 minute. Topic wise task. Uploaded textbook na? Textbooks. Okay, books. In that statistics. Just 1 minute. I am uploading the statistics textbook also for your reference. This is one of the book. You can select as per your choice. If you are having any other statistics textbook with you also, you can continue with the same. From my end, I am uploading one book for you. Okay. Just you can go through. This is the book. Textbook also I have added for your reference purpose. Okay. So other than this book, if you feel any other textbook is better or easy, miss, continue with that same. Whichever you feel easy, that is the best choice. Okay. And you can practice with multiple examples in this. You can go through everything. And as of now, just wait for tomorrow. And once tomorrow, entire descriptive statistics will be completed. From there, you can start doing the things. Tomorrow we'll complete the statistics, descriptive statistics. Okay. Yeah. Actually, last class, Saturday, we have to take the class, right? But in Naresh IT, some mock interviews are conducted. The entire building classes are filled with the mock interviews. They have taken the mock interviews for Java and for .NET and data science students. So they have conducted the mock drills and something. Tomorrow there is some kind of campus placement is going on. Not for you, for other batch students. Okay. For you, time is there now. Batch has to be completed now. If they do the mock interview or interview also, what you will do in that? I mean, if I give the job also, what you will do without completing the entire stage of data analytics project? What you will do with this part? Whatever you have learned today, with in the job, if you sit means you'll complete in 2 days. After 2 days, remaining part also you have to do now. So once we complete at the end, so similar kind for you also mock interviews will be done. Everything will be done. So that is the reason Saturday classes are filled and offline students are unable to, we have the class. That is the reason we are not able to take the class on the Saturday. Okay, we'll continue in the tomorrow's class. Done. If you are having any questions, you can ask. Yeah. Sir, in the histogram, the center portion is mean, while highest value is the median. Not highest value is median, highest value is called as maximum value. But which bin is the biggest bin is there, there the median will lie. Shrikant. Yeah, others you can leave. If no questions, you can leave. ప్రీవియస్ నోట్సా అప్లోడ్ చేశానమ్మా. స్టాటిస్టిక్స్ అండ్ నోట్స్ అని చూడండి, ఓపెన్ చేయండి. మీరు డ్రైవ్, నేను ఇక్కడే ఉంటా. ఒక్కసారి దీని ఏమంటారు, క్లాస్ 10:30 to 12 క్లాస్ అయిపోయాక మీరు ల్యాబ్లోనే ఉంటారుగా, ఒకసారి పైకి రండి 12కి ఒకసారి రిమైండ్ చేస్తే నేను మీ ముందే అన్ని అప్లోడ్ చేసి క్లియర్ చేసేద్దాం ఈరోజు. ఓకే, ఎనీ వన్ ఆఫ్ ద స్టూడెంట్ జస్ట్ at 12 o'clock.